Okay, so picking off where we left off at yesterday, we were talking about the quadratic formula, and that's our x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. Boom, okay? The first thing you want to make sure is that your equation is in order of power. So notice here how it's written as 7x squared minus 45x minus 28. That's how we know our A is with our highest power, our B is with our single power, and our C is our constant. It has no power, right? And then we just plugged everything in where they went, correct? So we were going through the process of evaluating where we plugged everything in. Anyone so far is lost to why we put things where they go? Good. And then we were simplifying, and we found that the square root of 28, 2,809 was 53. Okay, this plus or minus means that we have two problems that we have to evaluate. So we have to evaluate 45 plus 53 divided by 14. And we have to evaluate 45 minus 23 divided by 14. Make sense? All right, so here we have 45 plus 53 is going to give us 98. What is 98 divided by 14? 7. So from here we get x equals 7. Okay. On this one, we have 45 minus 20 minus 53. What does that look like? Because I wrote it that way. Minus 53. And that's going to give us a negative 8. So we get negative 8 over 14. So negative 8 over 14 can be reduced to what? Negative 4 over 7. So you leave it as the exact fraction. So we have x equals negative 4 over 7, and we have x equals 7. Okay, how do we feel about the quadratic formula? Okay, remember the quadratic formula is your catch-all, okay? So if on the test you're like, oh, I really am horrible at factoring, or I'm horrible at completing the square, if all else fails, what can you do? Quadratic formula. Okay. All right. So number 9, I'm going to pause for a second, and I want you to do number 9. Again, if you're just going to stare at me and never practice anything when I tell you to practice it, you're not going to get better in this class. It's just going to continue to be a hard year. So it would, even though it's So, did you notice this time that your square root didn't simplify? Did anyone notice that? Yeah? No? Maybe so. All right, let's double check. So here, remember your A is always with your x squared, your B is always with your x, and your C is your constant. So when you plug it in, you should have x equals negative B, that's a weird 3, plus or minus the square root of B squared minus 4AC divided by 2A. So a negative times a negative is a positive. So we have positive 3 plus or minus the square root. I have 9. You do this. This is 9, but you have negative 4 times 1 times negative 19 here. 76. So you do negative times a negative is a positive, and then you're going to be left with 76 plus 9, which makes 85 all over 2. And 85, can you simplify that down to any perfect squares? No. So guess what? This is where you stop. Okay. There's no way for me to reduce anything. 85 breaks down to be 17 and 5, which are both prime numbers, right? And so I can't continue to factor. I can't simplify. So this is where we stop. No, you cannot do plus or minus. It means a positive and subtraction problem. So notice right here, when it's set plus or minus, we created an addition problem and a subtraction problem.
Oh, last time did we ever square off the root?
We took the square root of 2,809, and it was 53. Yeah. All right. Any other questions about using the quadratic formula? Again, the reason why there's only 2 examples and we're not spending a whole day over this because this should be review. Okay. Good. All right. On to the next part. So here we have find the points of intersection of the graphs of the 2 functions. So we're looking for where do these 2 functions intersect. And when you're doing that, the number one thing you want to do is just set them equal to each other. So notice here how it says f of x equals g of x. That's how you find the point of intersection. You set the functions equal to each other. So we're going to set 4x plus 5 equal to x squared. Okay, because it's a quadratic, in order to solve, you're going to make sure you want to make it equal to 0. So we want to make equal to 0. So what do I need to do to make this equal to 0? Okay, if you move the x squared, it's going to be a negative. We try not to make it a negative, but so therefore you want your a to be positive when possible. So the key here is we want to remember that we want a to be greater than 0, meaning we want it to be positive. So we're actually going to move the 4x and the 5. So that's going to leave us with 0 equals x squared minus 4x minus 5. And again, guys, at any point you're not understanding this, please let me know, because when it gets to the quiz and you're just staring at it, that's not going to do anybody any good. Okay. All right. So x squared minus 4x minus 5. And then now you're going to solve for x. And you would use any skills that you have to solve for, whether it's factoring, completing the square, yeah, it was better, or the quadratic formula. So in this case, this is a simple factor. The reason why I know it's simple is because a equals 1. So I'm asking myself what multiplies to give me 5, but adds to give me -4. So what multiplies to give me 5, but adds to give me negative 5, adds to give me -4. A -5 and a +1. So x minus 5 and x plus 1 are my factors. And then when you have 2 factors, that means you're setting each factor equal to 0. So x minus 5 equals 0 means that x equals 5. X plus 1 equals 0 means that x equals -1. Because 5 minus 5 is 0 and negative 1 plus 1 is 0. Yes. Okay. Number 11 is an example of two quadratics and finding the intersection of those two quadratics. So we're going to do it together because the first one was a quadratic and a linear. Now we're going to do two quadratics and finding their intersections. To find the intersection again, the key thing is to set them equal to each other. So we have x squared minus 11x plus 24 equals 2x squared minus 12x plus 18. Your goal again is to make it equal to 0. So to make it equal to 0, what do I need to do? Well, I'm going to subtract x squared. I'm going to add 11x and I'm going to subtract 24. So on their corresponding parts, negative x squared plus 11x minus 24. These all cancel out and this side now equals 0. And on this side, I'm left with 2 minus 1 is 1. Negative 12 plus 11 is negative 1. And 18 minus 24 is negative 6. Again, this is a simple factor because a equals 1. So I asked myself, what multiplies to give me negative 6 and adds to give me negative 1? Say it again. Negative 3 and positive 2, right? Does that make sense? So we have 0 equals x minus 3 times x plus 2. That's because negative 3 plus 2 is negative 1. Negative 3 times 2 is negative 6. So again, I take my factors and set each one equal to 0. So x minus 3 equals 0 means that x equals 3. X plus 2 equals 0 means that x equals negative 2. Okay. How do you feel about finding the intersection of a linear and a quadratic and two quadratics? Seems doable. Okay. And the last part of this section is to be able to find the real zeros of a function. Okay. So this one is working with quartic functions. So these are called our quartic. Anyone wants to take a stab at why it's called quartic?
Oh, because of the four.
Because of the 4. So instead of quadratics, these are quartics, but they're very similar and they have the same behavior. Okay. So quartics and quadratics have similar behaviors, especially when you're solving and in their shapes of their graphs. So for solving, first thing you want to remember is, does anyone remember a difference of two squares? Dots. Does that ring any bells? Difference of two squares. So difference of two squares. So the difference of two squares is saying if you have a squared minus b squared, then they are going to automatically factor out to be the square root of a minus the square root of b times the square root of a plus the square root of b. Does that look familiar? Dots, hopefully. So that's going to be something that we all need to recall. So if you look right here, we have x to the 4th minus 81. Well, 4 is an even power and 81 is a perfect square. Does that make sense? So this is a difference of two squares. This is a dots situation. Okay, so because it's a difference of two squares, that means I'm going to take the square root of the a term and the square root of the b term. So a equals, what is the square root of x to the 4th? X squared. What is the square root of 81? 9. So therefore, this factors out to be x squared minus 9 times x squared plus 9. Mm-mm.
With the quadratic formula, what happens?
Yes. As long as you know that your b is 0.
Yeah.
Okay, so x squared minus 9, and you're going to set this equal to 0, because what are we looking for? The x-intercepts. And if we're the reason why we look for 0 is because that means y has to be 0 when we look for our x-intercepts. So I have two factors set equal to 0, which means I take each factor and set it equal to 0. So I have x squared minus 9 equals 0, and we have x squared plus 9 equals 0. What do we do to solve for x here? Before I take the square root, what do I need to do? Plus 9. So we get x squared equals positive 9. And now we can take the square root. And what is the square root of 9? It's positive 3 and it's negative 3. So here are my real solutions. Here, when I get here, I have x squared equals negative 9. What happens when you take the square root of a negative? Mm-mm. Does anyone remember what those numbers are called? When you take the square root of a negative. Imaginaries. There we go. Thank you. So we have an imaginary. So x equals positive 3i and x equals negative 3i. So they would be your imaginary solutions. Notice here how it said it only wanted your real. So notice I didn't box the imaginaries because it only wanted the real values. Is that little I ringing bells for imaginary? All right, the last problem is to show you how using quadratics still is applied. You didn't see that. So notice here how we have x to the 4th minus 37x squared plus 36. Essentially, all we did was double our x's, right? So instead of x squared and x, we have x to the 4th and x squared. That means it's going to work the same. So it's going to still be just working like it's a quadratic, but instead of 2 solutions, we can have up to 4 solutions, okay? So still, my A is 1, my B is negative 37, and my C is 36. If I didn't want to factor, could I use quadratic to start me off? I could, but this is an easy factor. So let's factor. What multiplies to give me 36, but adds to give me negative 37? There we go. So which one? But they are both have to be what? They both have to be negative. So our factors would be x squared minus 36 and x squared minus 1. Because a negative times a negative is a positive, and negative 36 plus negative 1 makes negative 37. Again, we're looking for the 0, so we're going to set this equal to 0. Okay, when I set it equal to 0, that means I'm setting each factor equal to 0. So you have x squared minus 36 equals 0, and you have x squared minus 1 equals 0. What do I need to do to get x by itself? Add 36. So we have x squared equals 36. Then what do I need to do? Opposite of squaring something is to take the root. What is the square root of 36? Positive and negative 6. And those are real numbers, so they count as real zeros. Okay, I'm going to repeat the same thing with my other factor. So this time I'm adding 1. That's going to give me x squared equals 1, taking the square root. And that gives us x equals positive 1 and x equals negative 1. Because when we take the square root of something, it produces a positive and a negative. So those would be my 4 solutions. So this quartic has 4 solutions, which means that it crosses the x-axis 4 times. And when we get into our polynomial unit, you'll see that in more detail. All right, that is the end of section 2.2. We will have a quiz on Thursday.